I'm Arthur, and I'm going to present you the whole project. So we choose to do an engaged show. It talks about ocean and the ocean pollution, and more specifically the phenomenon of turtles eating plastic bags instead of jellyfish. So to do this, we have 3 robots and light corals. Our main robot is Mary. It's a turtle. We built it upon a plywood plank, so it's like the frame of it. The shell is made of papier-mâché. It is a mix of glue and paper. We molded it on a real turtle shell, so it has the real shapes of it. We also added a plywood plank beneath it to have more rigidity. We also built the 4 legs and the queue. And for the head, it is built with 3D printing, and it can also opens to show the camera underneath it.
So inside the turtle, we can see a lot of things, but it mainly relies on 2 Arduinos, one Mega and one Uno. The Arduino Mega does every movement, so it controls the Omni wheels or the Mecanum wheels and the servo motors to move the legs. The Arduino Mega is responsible for every movement, so the movement of the turtle that also relies on Mecanum wheels or Omni wheel to move in any direction without turning, and servo motors to move the legs and the head also of the turtle. It also receives the signal from the camera. The camera will tell where the jellyfish or the trash bag is compared to the turtle, so it will allow the turtle to move and go to the jellyfish, for example. Then there is the Arduino Nano that is responsible for every sensors and the wireless communication. The Arduino Nano will tell every distance from our ultrasonic sensors to tell if the turtle is running towards an obstacle, and it will also tell if we have an XB module to the coral to light up in a specific color depending on the situation. So if the turtle is running towards the trash bag, all the colors will turn red, and if it runs toward the jellyfish, all colors will turn green because it's the thing she's supposed to do. The turtle is powered by 1 LiPo battery, but it's diverse to multiple circuits. So every Arduino is directly connected to the battery because I have embedded voltage converters, and it's easier to plug them. And there is also power directly coming from the battery to the motors, so they can turn faster. Finally, the servo motors need 5 volts, so we have a DC to DC converter, a step-down converter to convert the 14 volt from the battery to 5 volts for the servo motors.
I'm going to present you the jellyfish robot. So at first it was an M-bot, but we decided to upgrade it to have more difficulty. So now we have Arduino Nano and a motor controller instead of the M-bot card. We place the batteries here. We have a line detector, and we kept only the motors and the wheels from the M-bot. We placed an interrupter here to put on or off the robots. We also use LEDs, blue LEDs here. I will show you later. For structural purpose we use a carbon fiber tube, but also metal and plastic plates. The jellyfish itself is composed of paper with a metal grill inside, and we placed a bit of paper and plastic to have a real jellyfish aspect. I'm just going to put it on.
So, hello, I'm going to show you the inside of our trash bag robot. So its robot is in two parts. So the Arduino part and the Raspberry Pi part. So on the Raspberry Pi part, you have here the Raspberry Pi. Inside of the robot, you have the webcam here, who is connected with the USB to the Raspberry, and you have here the battery, who deliver all the power needed for the Raspberry. So you probably wondering what the robot do on the show. So it's very simple. You just use your hand gesture to move on a certain side or another side. So for example, I'm going to show you. If I show my hand like that, it's going to go on this part, and you can see right there that it's been stopped because the line is black, and when the line is black, the robot stops himself. It's in the Arduino part of the robot.